Hi there. Welcome to the second video of how to make a real-time strategy game. Yeah, real-time strategy game, that's got to be really easy to make, right? It'll only take a few videos. We're nearly there, right? Well, let's see where we left off in the last video. So the trucks go to the coal deposit, pick up coal, and then drop it off at the coal power plant. The power plant then creates electricity. It is connected to the transmission tower, which is connected to the lamps and powering the lamps, and also connected to the battery. So if the power plant goes down, as long as the battery has electricity, it will then be used to power the lamps. There was a game I liked in the past called Tropical 5, and it had an electricity mechanic. So electricity was used to power factories to make them more productive. It would also use to make people happier in terms of probably giving them air conditioning. I think that's how it worked. I really liked that game. There was a few things I did not like. So one of them was that the player actually had to handle the navigation in terms of building roads everywhere. I would prefer if that was automated. The other thing I didn't like is that when the power plant ran out of coal, you would have to get coal to it as quickly as possible. However, unless maybe I played the game wrong, the coal logistical system could take months to get the coal delivery. And of course, that pretty much shut everything down. So in this video, the trucks will be getting collision detection, so they do not go through each other. They're also going to now dock to buildings rather than just materialize inside of them. There's also going to be a priority system where if you really need something delivered in a hurry, you'll be able to do that. In addition, I'll be putting a building that actually builds more trucks and a way for it to procure resources to build trucks, and also a building that can build other buildings and a vehicle that builds other buildings. Well, let's see how it goes. So now I have something I call the truck park. So that's a way you could dock to buildings. So let's see how that works. All right, that's the coal factory as always. And now we're going to show the vehicle is actually able to dock to it instead of going inside of it. There's still no collision detection, and if two things try to dock at the same time, well, they could do it at the same time. Well, that's not that good. So I'm going to show in Blender how the animation is done. It's actually much easier than you think. So I'm going to start by making two cylinders. So this represents the robot arm. So I'm just going to scale it and make it a bit longer. Then I'm going to duplicate it. So I'm going to have a second one. Now it's interesting here. So we're going to actually make the bones there, so to speak. And we're going to go into, well, first we're going to scale them. Then we're going to go into edit. So once we're in edit mode, we could then extrude to get a second one. And if we hold down the Z button, that'll make sure it goes perfectly on the axis. Oops, wrong one. Now we're going to go into the cylinder, and this is interesting. So we're going to click on the cylinder, then we're going to click on the bones and go make parent. What that means is anything that happens to the bones will also affect the cylinders. So we're going to go in pose mode and show that when we rotate them, we rotate the cylinders. Pretty cool, right? Really easy. So we're going to want to animate this. So how this is done is by placing keyframes. So the first thing is we'll do our initial keyframe. So it has a start. Then we're going to be advancing the timeline, do a single rotation, and place another keyframe. Now, if you go back and forth, it will interpolate over these keyframes. I'll do one more rotation. Put another keyframe, and there it is. Pretty much exactly like the one you see in the actual truck park. So it's really easy. It's really fast. It's not too challenging. So let's try again with a coal power plant and see what happens. See if it improved from last video. And it looks the same so far, but there's going to be something different. Aha. It seems to wait for its turn to go in. Kind of. You'll notice that it's a bit glitchy, and especially when you actually come from a different direction. And when I was trying to figure out how to code this, the biggest mistake I made was just looking at this scenario. You're just trying to solve it like from one path. And there's actually a relatively simple solution if you think about it from a general sense, but I wouldn't get there for, well, at least several more videos. So I also have the ability to build a building that could build other buildings. So let's also build the construction truck. And you would have the option to build, well, you only have 4 choices. So we'll build a lamp. You can see it being built. And then we'll drive the construction truck in. And it's actually going to get the building placed on top of it, although it's only a square block. And now we can go ahead and build it. Now, how I do this is first you actually place it somewhere you could place it. Then you go near it and you right click it and it kind of gets built. Now let's look at some code. So one thing that was done now is that every model in the game has a unique number. So we have a static, which means it's once per program. So we start at 0. Then every single time we make an object, we take the number and then we increment it. So the first will be 0, the next will be 1, the next will be 2. Now, why do we do this? Well, it's an RTS, so things will get destroyed. So if we're trying to get a reference to something, if we're referencing memory that was essentially no longer available, we get some kind of error. So instead of this, we have a dictionary, and the dictionary has a key value pair. So the key is that number, and the value in this time is actually a number for an array, but later on it decided just to use a memory reference. It also makes saving and loading much easier. So the action model is an RTS model now, so is the building. Now, if you notice, the building has a truck queue there, and guess what that integer is? Well, shouldn't be hard to guess. It's actually, obviously, the number, the index of the RTS model. So it's a way of getting a reference. So if it needs to say truck, go forward, it has a way of accessing the truck and telling it to do that. So one other thing here is the shader. This is how the buildings are being built from the bottom up. So you're just sending it a height cutoff, so from 0 to 100, and you're just checking its Y position and seeing if it's greater than or not, and you can see that below. And basically, you're either drawing the building color or an alpha value. There's a new building now. There's a building that builds trucks. Let's see how it works. Click the button. Oh, here comes a new truck. Cool. There's another new building, the silo, and the silo, well, obviously stores resources. So let's see it get a coal delivery. Now you may notice there's actually another difference, and you'll notice how much smoother the movement is. I've went ahead and stopped using the grid-based navigation, and I'm now using the Godot nav mesh. And it's way better, it's way smoother. All this code is pretty much from the Godot documentation. The only thing they ask you to do that if you're doing this in real time, that you use your own objects rather than use the Godot built-ins. Unfortunately, there's a bug in there somewhere, and it took me a while to figure out what it is. I'm not quite doing it as intended. When the nav mesh is done and it runs in its own thread, function gets called, and you know it's ready to go. Now, I did some performance testing. Turns out the nav mesh is 10 times faster, and that is in a relatively small map, and it's roughly the same amount of time to compute. I realized that when I change the grid size, it'll be roughly the same. Another thing that was added, and this is for the silo, is now a way to store resources. So obviously you have coal, metal, mineral, energy. However, this is actually wrong. It was later changed. We're going to show you how you're supposed to implement it. Yep, you go enum, coal, metal, mineral, energy, and so on, and whatever else you need, and you're just going to have an amount, because that's actually kind of limiting how it's implemented. There is now collision avoidance for the delivery trucks. Well, it mostly works. The silo now has 2 truck pads and can handle simultaneous deliveries. It still glitches a bit. There is also a way to view the status of the trucks. The trucks run on battery power, so they need a way to recharge. There's now a recharge port that needs to be connected to power to work. Let's see it in action. In case the trucks run out of power, there's a tow truck that is able to take a truck to the recharge port. The coal deposits now have a way to dock to it without going inside of it. I improved the collision detection of the trucks. to use bounding rectangles so they can pass by. On the bottom, there is a console to output messages. I implemented a truck logistical system. Rather than click on a location for a truck to do delivery, they are now ordered around using a menu system. So I could send one truck on a full order. I could also send multiple trucks and have a larger continuous order. If all the trucks are on a delivery, well, how does the coal power plant get its coal? While using the priority system, it could get the next available truck. Trucks are also used to deliver supplies to the truck factory, which takes priority over other scheduled deliveries. I had two goals. The first was to have trucks be able to deliver without having the player to build roads. The second was to have a priority system to deliver goods, both of which were kind of accomplished. But how much of this month was actually used in the game? As it turns out, most of the models were scrapped. The coal idea was scrapped. The collision avoidance had to be improved, actually many times, and the delivery system was simplified from a menu to delivery button on a building. I started on the framework for the code, much of which had to be improved. I didn't realize it at the time, but the primary accomplishment this month was not the models, the code, or the mechanics. It was a learning experience. I'm guessing that if the game engine code and the mechanics are being developed at the same time, there are always going to be months like this. Well, thanks for watching.